GRIAS Academy.
100 days, 100 themes, one goal, UPSC Prelims. Hello all, welcome back to the program Mission Surya Phase 3, a STEM revision program where we are going to deal with science and technology and environment related current affairs in completely prelims perspective. So let's get started with our today's session. In our today's session, we are going to see few climate and environment related things, in particularly the pollutants. Okay, now let's get started. Our first topic is particulate matter PM 2.5 and particulate matter 10 standards, sources and crisis. We'll see about this particulate matter. What is this particulate matter basically? Particulate matter is a solid, tiny, solid and liquid droplets, okay, which are formed by the dust particles and all, okay. So basically this particular matter is particulate matter is a solid and liquid droplets which are formed by the dust particles, basically the dust particles and few like what you called emissions, through emissions and smoke, etc. Many particles which constitute and they form a small tiny particles. These few particles, this particulate matters are even not visible with the naked eye sometimes. So what happens, even they are not visible with the naked eye and easily enter into the human body and it affects the environment more. Okay, now see. Air quality across India worsened in October 2025 where a CREA report stated. Okay, what is the CREA report? CREA means Center for Research of Energy and Clean Air. Okay. This is what CREA report is. It will release a report which is for the air quality. Okay. Now, recent findings from the state of global air and 2025 and the air quality life index 2025, which underscores a catastrophic public health care, means a massive health care, okay, emergency. In 2023, what happened? The atmospheric pollution claimed approximately 2 million lives in India due to the atmospheric pollutions and all. 2 million lives have been ended in India in 2023, accounting for a staggering 52% of global mortality is linked to poor air quality. Okay, next, this is the current context of it. Moving on, let's compare what is this PM 2.5 and PM 10. Okay, now what is this PM 2.5 particulate matter 2.5? What will this state? This is like measuring under 2.5 micrometers to see, it is written like this, right? PM 2.5, in the sense the particulate matters which are less than or equivalent to 2.5 micrometers. Okay, these microscopic particles basically, can we see a small piece constituting of 2.5 micrometers? No, right? So they are microscopic particles like heavy metals, organic compounds, smoke. Okay, these primarily originates from the process of combustion through like vehicular exhaust, biomass burning, thermal power plants and all. Can we see those? No, right? Okay, now let us see the pathological impact of this, what it causes to the human. Means their minute size, because of their minute size, they allow them to bypass the respiratory defense. They can allow through the respiratory defense which infiltrating deep lung tissues, which infiltrates into the deep lung tissues and crossing the blood and brain barriers. This triggers neuroinflammation. It causes what? Neuroinflammation, cardiovascular anomalies, strokes and severe neonatal complaints like preterm deliveries. They can cause to preterm deliveries also. Okay, next, this is about particulate matter 2.5. Now particulate matter 10, which is a coarse particle. These are coarse particles like measuring up to 10 micrometers, 2.5 micrometers visibly and 10 micrometers. Compare. These include mold, the pollens and the dust majorly. Okay. They are primarily stripped up by wind erosion. They are primarily stripped up by what? Wind erosion, soil or road resuspension and construction works. What is the effect of this on human? The pathological impact is these predominantly irritate and damage the upper respiratory tract. Upper respiratory tract is being damaged by this particulate matter 10. Okay. Next. Moving on. Yeah, you can see the sizes here also. See, this is the human hair scale basically. This is the thing like 5 to 10, 180 micrometers, and this is what you call fine beach sand of 90 micrometers. This is the grain salt which is 60 micrometers. This is the white blood cell which is 225 micrometers in size, and grain of pollen which is 15 micrometers, and the dust particles, the PM10 are in 10 micrometers, less than 10 micrometers are red blood cells which are 7 to 8 micrometers. Respiratory droplets are the respiratory droplets 5 to 10 micrometers, dust particles 2.5 micrometers, bacterium, the what you call cocoids and all, which you can see in 1 to 3 micrometers of size. Wildfire smoke 0.4 to 0.7 micrometers of particles will be released. Okay. Next, coronavirus, which is very small, 0.1 to 0.5 micrometers of size. Okay. This is like this. The scale is so. Okay. Now, moving forward. Based on this only, they can easily enter into our body because it will be traveling in the air, right? These particulate matters, when they are in air, when we breathe also they go inside this, particularly this particulate matter 2.5. Okay. So, yes, these are the pathological impacts of particulate matter 10. Next, our next thing is regulatory divergence, WHO guidelines versus Indian NAAQ. NAAQ is National Ambient Air Quality Standards. Okay. NAAQ is National Ambient Air Quality Standards. See, coming to WHO guidelines, what it is, it sets stringent global safe limits. Stringent global safe limits like PM particulate matter 2.5. Particulate matter 2.5 is 5 micrograms per cubic meter annually, it has to be there, and 15 micrograms per cubic meter for 24 hours. This is the standard. Okay, it sets the stringent safe limits for the global environment. Okay, who sets this? WHO, World Health Organization. And coming to PM10, it gives the standard of 15 micrograms per cubic meter annually and 45 micrograms per cubic meter for 24 hours. This is the standards which is set by the WHO. Coming to the National Ambient Air Quality in Standards, what is the standard which is set by this NAAQ is? It is enforced by India's Central Pollution Control Board. Central Pollution Control Board, these are drastically more lenient than the WHO standard. Like how? See, PM 2.5, particulate matter 2.5 must standard is set to 40 micrograms per cubic meter annually. Means see, here it is annually 5 micrograms per cubic meter which is set by the WHO, but in NAAQ it is set for 40 micrograms per cubic meter, means it is 8 times more than the WHO standard which is set. Okay, and 60 micrograms per cubic meter for 24 hours. This is also way more high. Okay, now coming to the particulate matter 10, which is 60 micrograms per cubic meter, which is set to annually. These are the most lenient, most lenient limits which is set by the NAAQ. Okay, next. Next thing is socio-economic and demographic impacts. What are these PM particulate matters do to the socio-economic and demographic impacts is, despite India's high relaxed standards, 46% of the national population, 46% of the national population resides in the zones which are breaching the 40 micrograms per cubic meter of particulate matter 2.5 limit. Okay. Next, consequently, India is currently home to 13 of the top 20 most polluted cities globally. Out of 20 cities which are most polluted globally, India stands in the 12 top 13 countries are from India only. Okay. Bridging the gap to meet the WHO guidelines, bridging the gap which the WHO and NAAQ has given these limits for particulate matter, to bridging this guidelines would yield massive demographic dividends, like an average life expectancy increase of 3.5 years nationally. 3.5 years of increase in the life expectancy may happen, and an unprecedented 8.2 years for Delhi residents. Mainly for Delhi residents, 8.2 years. Okay. Next, moving forward. Our next topic is the rising menace of secondary pollutants. We have seen in the previous classes the primary pollutants and secondary pollutants, right? Primary pollutants and secondary pollutants. What are these primary pollutants? Primary pollutants are released from the direct sources. Direct sources like vehicular emissions, this AC emissions like chlorofluorocarbons and hydrofluorocarbons. These are the primary pollutants. What are the secondary pollutants? Secondary pollutants are when these primary pollutants upon reaction with sunlight, which undergoes some chemical reaction and produce the secondary pollutants. Upon going through chemical reaction, it produces the secondary pollutants. Okay, these are the secondary pollutants. Okay, so now in the atmosphere globally, secondary pollutants content is increasing more. See, it is stated like this: secondary pollutants behind 50% of PM 2.5 in India. Above the PM 2.5 in India, 50% of the pollutants is the secondary pollutants, which is stated by CREA study, which is mentioned in the Hindu. Okay, in early 2026. Okay, next, let's see the current context. What is it? A 2025 analytical report by the Center for Research on Energy and Clean Air, CREA, it highlights a paradigm shift, like what? Secondary atmospheric chemistry rather than the direct tailpipe emissions now drives nearly 33% of India's PM 2.5 burden. 33% of PM 2.5 burden is the secondary pollutants. Okay. Now, coming to the mechanics of formation, how these are formed. Unlike the primary pollutants like dust, direct sulfur oxide, NH3 and all, secondary pollutants are not directly discharged. They are synthesized aloft via complex physiochemical atmospheric reactions catalyzed by ambient heat and sunlight. This is how the secondary pollutants are produced. Okay, this is how the mechanism of secondary pollutants. Now, let us see few key secondary pollutants. What are they? The first one is ammonium sulfate. Ammonium sulfate, which constitutes of 34% of India's PM 2.5 mass. Out of PM 2.5 mass, the ammonium sulfate consists of 34%. Okay, it is formed when sulfur dioxide, this S2SO2, is oxidized and binded with the ammonia, and it is binded with the ammonia, it forms the ammonium sulfate. Okay, because when the coal-fired thermal plants emit greater than 60% of India's ammonium sulfate, India's ammonium sulfur dioxide. Okay, ammonium sulfate concentration peaks drastically, approximately to 15 micrograms per cubic meter. Okay, within a 10 kilometers radius of these facilities. Okay. Though transboundary winds disperse it over vast geographical areas. Okay. This ammonium sulfate is constituting for how much amount of particulate matter? 2.5 in India. It is 34%. Okay. Next, the next secondary pollutant is the tropospheric ozone. Tropospheric ozone, that is the surface ozone. Means unlike the protective stratospheric ozone, which is there to protect us from the direct sun rays to the human, this is the ground level ozone, which is highly toxic greenhouse gas. It is a highly toxic greenhouse gas. It synthesizes when nitrogen oxides reacts with the volatile organic compounds. When this nitrogen oxide reacts with the volatile organic compounds, okay, VOCBs, okay, and carbon monoxide under intense solar radiation. In the high temperatures, when nitrogen oxides reacts with the volatile organic compounds and carbon monoxide, they form the tropospheric ozone, which is very harmful greenhouse gas, rather than the stratospheric ozone, which is there to protect us from the direct sunlight. Okay, this is one of the another pollutant. Coming to the next pollutant, it is human impact. What is the human impact of it? Let's see first. It generates reactive oxygen species. It generates what? Reactive oxygen species, leading to severe oxidative stress. That damages the DNA and cellular membranes. It even damages the DNA and the cellular membranes of a human. Okay, now coming to the agricultural impact of these pollutants, it severely disrupts the photosynthetic pathways. Basically, plants live in the process called photosynthesis, right? They prepare their food through photosynthesis only. So, because of these pollutants, what's happening? The photosynthetic pathway is also being disrupted. Okay, of staple C3 crops, such as rice and wheat. Due to this high emission scenario, threaten to splash crop yields by up to 20%. Crop yield is slashed up to 20% due to these emissions. Okay, these are the major impacts on human and agriculture by the secondary pollutants. Next, our next concept is the climate penalty phenomena. Okay, see, while nitrate oxide is primarily a byproduct of high temperature fossil fuel combustion, like from industrial boilers, from vehicles. This is nitrate oxide is released. Okay, this VOCs, I mean the volatile organic compounds, traditionally stem from solvents. They come from the solvents and fuels. However, recent scientific evidence shows that few urban trees under severe sunlight, higher temperatures in the summer times, stress release biogenic volatile compounds. Okay, from the trees, few urban trees upon engaging with the high sunlight during the summer times, it is releasing biogenic volatile compounds, which are natural emissions which is synerged with the anthropogenic nitrogen oxide to hyperaccelerate surface ozone formation. This is the main main reason for the formation of this tropospheric ozone. Okay, a viscous cycle where global warming exacerbates local pollution independently of direct human activity, known as the climate penalty. This is what you call climate penalty. Okay, next. The next one is decoding the Delhi NCR winter smog crisis. Decoding the Delhi NCR winter smog crisis. Okay, now see, 204 out of 238 Indian cities, 204 out of 238 cities of India did not meet air quality standards. Which is said by the CREA in the Hindu in March 7, 2026. What is it? We will see the context of it generally. According to the CREA 2025 data, Delhi did not register a single good air quality index day in the entire year. In the entire year, not even a single day is a good air day in the Delhi. This is what given by the CREA 2025 data. Okay, underscoring the failure of conventional hyperlocal mitigation strategies. Okay, due to the conventional hyperlocal mitigation strategies. Okay, next. Coming to the geological and meteorological vulnerabilities of this Delhi, first is the Indo-Gangetic topography trap. Due to the Indo-Gangetic topography trap means, let's see that Delhi sits in a flat, low-lying atmospheric bowl. Generally, in Delhi is not even covered by any coastal areas here and there. It is between, which is very hot. Okay, it is completely a landlocked area. So that's why it states that Delhi sits in a flat, low-lying atmospheric bowl. Right? The towering Himalayan ranges which are near to the Delhi, to the north acts as an impenetrable physical wall. They acts as an impenetrable physical wall which blocking the natural northward dispersion of aerosols. Okay, usually the Himalayas are very good to the country, but however they are to the northern cities it is very bad because it acts as an obstruct, right? See, when mountains are like this, when wind is coming, will it block or else will it allow the air to move into the areas around? No, it will block the wind also. Okay, this is the first geographical vulnerability, like it sits in the Indo-Gangetic topographic trap. The next one is temperature inversion. Temperature inversion in Delhi is very common because see, during extreme winter nights, everyone knows in the winter in northern states, mostly we can see snow or else the smog, right? So, rapid cooling of the earth's surface creates a warm air lid. It creates a warm air lid aloft. Okay, this inversion pins frigid toxic air directly to the ground. It pins the frigid toxic air to the ground directly, entirely paralyzing vertical atmospheric mixing. Obviously, this vertical atmospheric mixing is completely paralyzed because of this process, like this frigid toxic air which is coming directly to the ground, which is making the vertical atmospheric mixing completely paralyzed. Okay. The next concern is urban wind stilling. Urban wind stilling means the dense concrete infrastructure severely damps nocturnal surface winds, dampens nocturnal surface wind speeds, often dropping below 5 kilometers per hour. Night time the winds are very low because see, in Delhi and highly populated states we can see buildings are very close to each other. There won't be even a space, not much space to move with lofty buildings, right? So in that way this creates urban aerosol clean islands, which is a paradoxical effect where towering structures means I've told you loft buildings, very huge buildings, tall buildings, block incoming regional dust. It blocks the incoming regional dust and simultaneously suffocate the city by trapping what? Internally generated emissions. Obviously all the emissions which are released by these cars, the ACs and all, these are completely blocked in the city. They are not even going to the atmosphere and coming back. Okay. This is what happening in the cities like Delhi and the high polluted cities. That's what we call it urban wind stilling. Okay. Next is evolving emission dynamics 2025 shifts. Evolving emission dynamics. The first one is transboundary dominance. In the sense hyperlocal bans are proving ineffective. They are proving ineffective. Which one? Hyperlocal bans are proving ineffective because 65% of Delhi's pollution is imported. 65% of Delhi's pollution is imported from neighboring states and peripheral NCR districts. It is not only Delhi, it is from the the other states which are near to the Delhi, from there also this pollution is coming to Delhi itself. Okay, next is the vehicular supremacy. Vehicular supremacy. Within Delhi's local generation matrix, vehicular exhaust has emerged as a therapy contributor, accounting for nearly how much? 50% of local PM 2.5. Okay, next. The next is the stubble burning decline. The stubble burning decline means it is challenging popular narratives. The contribution of agricultural fires plummeted to just 4.9% in the 2025 season. How much? 4.9% of the 2025 season, which is a steep drop, very a drastical drop from 15.5% in 2025 to 4.9% in the 2025. Imagine such a drastic drop in it. Okay, proving that urban year-round sources are the true anchors of the crisis. Urban round sources are the true anchors for the crisis. Okay, next. The next is, let's look into the governance framework. Okay, someone has to be there to control this pollution and all, right? So in that case, we'll see the framework here. To manage peak pollution, the Commission for Air Quality Management, triggers the Graded Response Action Plan. It triggers the Graded Response Action Plan, which rolling out staggered emergency restrictions based on real-time AQI, Air Quality Index determination, which is stage 1 to stage 4. Stage 1 is poor and stage 4 is severe plus. Okay, poor, severe 1, severe 2, like that. It is severe plus. Stage 4 is severe plus. Stage 1 is poor. Okay, in this standard the AQI has come up. Okay, this is the governance framework for the pollution. The next topic is the flue gas desulfurization conundrum. Means, what is this flue gas desulfurization? Is removal of sulfur dioxide from the inert gases, from the exhausted gases which are released by the thermal power plants and on. Okay, which are released from the thermal power plants. The name itself states desulfurization means removal of sulfur dioxide. Okay, now see, Central Pollution Control Board to decide on future of flue gas desulfurization units, which is given by the Power Minister in the Hindu in June 11, 2025. Okay, what is the current context of it? A major policy debate erupted in June 2025 when a government committee led by the principal scientific advisor recommended scrapping the 2015 blanket mandate that required all Indian coal-fired plants to install FGD systems. All the thermal power stations which is using coal has to install FGD systems. This is flue gas desulfurization systems, which is pitting public health directly against energy economics. Okay, this is the current context. Let's see the technological framework of it. What are these FGD units? FGD units are vital scrubbers, which are the vital scrubbers integrated in the thermal power plant, which exhaust to neutralize the sulfur dioxide which is being released from it. Okay, next. It's the same in this. We have wet limestone scrubbing. One of the technique is wet limestone scrubbing, where the industry standard boosting 90 to 95% efficiency. Toxic flue gas interacts with the basic limestone. A toxic flue gas interacts with the basic limestone and water slurry like CaCO3. Okay, that absorbed sulfur dioxide chemically, which transforms into gypsum, which is a monetizable byproduct utilized in the cement sector. It is a byproduct which is utilized in the cement sector. Okay, this sulfur dioxide is converted into gypsum by various chemical treatments by using the flue gas desulfurization technique. Okay, next coming to the implementation hurdles and rollback logic, we'll see the Ministry of Environment and Forest and Climate Change has originally mandated 537 plants. Originated how many? 537 plants to install flue gas desulfurizations by 2015. Okay, through successive deadline extensions to 2027 to 2029. Only a ambismall 39 plants had compiled by April 2025. Rather than they have estimated for adopting 537 plants throughout the India, but however by April 2025 only 39 plants have been installed. The FGD systems have been installed in the thermal plants where coal is being used. Okay, see the economic agreement. The economic argument is PSA committee where it says FGDs require massive capital expenditure. It needs a massive capital expenditure which is approximately 1.2 crore per megawatt, rupees 1.2 crore per megawatts, which is equating to a national burden, of nearly 97,000 crores. 97,000 crores. This would inevitably forces consumer electricity tariffs by up to 0.62 to 0.72 per kilowatts per hour. Okay. Now, consequently, the committee advised restricting the FGD mandates exclusively to plants burning high sulfur, which is greater than 0.5%. If any thermal plants which are giving out the sulfur, burning the sulfur more than 0.5%, that plant should have the FGDs. It is mandated to have the FGD in the thermal power plant. This is said by the committee, the PSA committee. Okay, or imported coal. Okay, next. The next one is, let's see some critical counter preservatives. Okay, critical counter preservatives. The health argument is derailing national targets. Like how ecological experts warn that abandoning FGDs, abandoning flue desulfurization techniques will fatally compromise the 6,000 crore national clean air program. Okay, because sulfur dioxide is the precursor to ammonium sulfate. It is the precursor for ammonium sulfate, which unchecked coal emissions will guarantee a continuous supply of secondary pollutant of particulate matter 2.5. Okay, next, the coal washing fallacy. It is what? Proponents of the rollback often cite. Which is coal washing as an alternative. Coal washing is an alternative, while washing successfully removes external dirt and ash to boost thermal efficiency. It is chemically incapable of extracting the sulfur bond between the coal's intrinsic molecular structures. Therefore, FGDs remain the sole scientifically viable intervention for SO2 mitigation. Okay. So today we have seen few climate related and environment related current affairs which we have seen in the Hindu newspaper and all, and we have elaborated this with the few static part also. So I hope everyone liked this video. If you want a detailed content note on it, please visit our website where you will find the note and you can download it from there. The link is provided in the description box below. And do like and subscribe our YouTube channel so that it will be helpful for you for your next UPSC exam, coming UPSC exam in your current affairs. And do follow our Telegram channel as well as the Instagram channel for your UPSC preparation. And I'll see you all tomorrow with another session of environment and science and technology content. Thank you.